Okay, in this one, you can see I've already done a little bit of pre-work. Got all of my variables listed. And we're gonna go ahead and start solving these problems, solving these answers. So for the first one is, what is the total momentum before the collision? So before collision, I'm gonna take the mass of the truck times its initial velocity plus the mass of the car times its initial velocity. And when I multiply that, this is essentially 0 because of anything times 0 is 0. So 2400 times 9.6, and you get 2340 kilograms meter per second. Now for part B, it asks for the final momentum after, or for the momentum after the collision. So I'm gonna take the truck mass, 2400. At the end of the collision, it's going 4.6 meters per second. So 2400 times 4.6, and we get 11,040 kilograms meter per second. Then it asks, what is the momentum of the car after collision? So this is where we have to figure out what our change in momentum is going to be. In order to figure out the car, we're gonna have to start with figuring out what the change was. So I'm gonna look at the truck. Since I have a before and after for the truck, I'm gonna use that to figure out what my impulse is. So I'm gonna take 2340 minus 1140, which is gonna equal 12,000 kilograms meter per second. Okay, so it lost 12,000 meters per second, kilogram meters per second in momentum. Technically I should have had these switched. I should have done my PF minus my PO because it would be negative because the truck lost, but since we're going to be looking at what the car gained, it's okay that I left it this way. So I'm going to take that. My original momentum of the car was 0, so I'm going to take 0, and it's going to gain 12,000 kilograms meter per second. So its new momentum is 12,000 kilograms meters per second, because if that's how much the truck lost, that is how much the car gained. So now let's go into D. That is also going to be the impulse of the collision, because again, that is how much one vehicle lost. That is the change in momentum between the two vehicles. And E, we're going to get down to the force of impact. Okay, so for this one, the force of impact, I have my impulse and I have my time. So to find my force, I'm going to do 12,000 divided by the 0.6. And that's going to give me a force of 20,000 newtons. That is the force of the impact. Now I know it doesn't say it here, but if I wanted to take this one step further, and let's say I wanted to find the final velocity of the car, all I need to do is take that final momentum, okay? Take part C, the final momentum of the car, take that 12,000 and divide it by the mass of the car, and I would get a momentum of 10.91 meters per second. And since it is positive, it means it would be going to the right.